Hi everybody. We're going to do some nice stuff in R today, and you're welcome to use R Studio if you wish. I just like R. Okay, so what I'm going to do is install a package called CAR, C-A-R, if I can spell. And it has a bunch of dependencies. Now mine won't show it because I have loaded it before. And I'll use Austria like I always do, because I'm weird. This has 4. On yours, it'll probably have a bunch more. Okay. And I'll type in library car. Now, car is actually a regression library. And we're going to do a lot of stuff in here. And we're going to do some of this. Right now, we're going to do a review of what we did a couple weeks ago. And then we're going to learn some new stuff via some YouTube movies. Okay? So let's talk about a particular data set that's in here. And I'm going to attach that data set, and it's called CANPOP, which is actually, because I spelled it wrong. Okay. What's in this? I bet it's Canadian population. Why, yes, it is. All right, and it's a data frame. It has 2 columns. One is a year, the other is a population. It's actually a time series. It's decennial, which means every 10 years. And normally we don't use regression on time series, but we're going to do it this time. What the heck? And run some of our stuff and see if we see anything interesting. Okay? So I'm going to close this out. I'm going to go ahead and clear the screen, and it won't do it because I'm on the Mac. Let's have a little space here. All right. So I'm going to set up pop.lm is population tilde year, and its data equals canpop. And let's look at the summary. Okay. So let's think about the questions that I typically ask. So I might say, test the claim that beta equals 0. Should say beta 1 equals 0. And I might say find residual standard error. Find R squared and find adjusted R squared. Okay. So I'm not going to write out the steps for the test. But we would say beta 1 is equal to 0 versus beta 1 not equal to 0. The test statistic we would use would be the 4.96 e to the minus 0.9. We would say if p is less than alpha, and let's assume that alpha is equal to 0.5, then we would reject HO, and we would think, is that less than 0.5? It certainly is. So we would reject HO. Therefore, the year has meaning in this model. So this is a good model. Okay? Now, residual standard error is 2.652. So that's really the sigma hat of the model. Okay? Or, yeah, it's the sigma hat of the model. Sorry. Okay. The regular R squared of the entire model is 0.919, so that's pretty good. The adjusted R square is 0.9133, also good. Okay. So that's pretty typical stuff for a 2-variable model. All right. So that's what we have so far. But there's more.